Our lesson today is over function operations and composition. And this part I think is always a little bit fun. I know that sounds a little bit weird regarding math, but I do view it as fun. We're going to look at the way we compose a function. So this is using operations. So what we're saying here is, let's kind of go backwards. If I want to take f of x and add it to g of x, then I'm going to write it as the function's f plus g of x. The same thing here. If I want to subtract, I do f of x minus g of x. I'm going to write it f minus g of x. And this is what we will show you as the shorthand notation, and you would expand it out this way to follow what happens. Now here is the trick. This subtraction sign is key. So I'm going to put a big arrow by it, and I'm going to bring that up again a little bit later on, so don't lose track of that minus. On the other side, we're going to combine multiplication and division. If I want to take the function f of x and multiply it to g of x, it would look just like this. Notice right here that we're putting that multiplication sign, that dot, back into stuff. We don't want to use an x. Those are variables for us. And we're not going to just run them all together using additional parentheses. Here, we're dividing, and it looks like this. The caveat is g of x can never equal 0. Remember, if it ever equals 0, we have an undefined function. Okay, we've actually created an asymptote there. Okay, so remember, whatever we put down here, we're going to be making an exception for, which you'll see momentarily. So I'm going to start here with these two examples. Under example 1, we're going to use f of x and g of x. So the first one that I'm going to do is f adding to g of x. Okay, so if I was going to continue from there, my next portion would usually be 4x plus 7 plus 12 plus x. And I'm going to keep that in parentheses right now just to make sure there's nothing I need to run through. I don't, so ultimately I just have 4x plus 7 plus 12 plus x. Notice now, I want to combine like terms. So I have my x's, and I have my numbers right here. So my final answer is going to be 5x plus 19. Notice that once I start my procedure, I'm holding my equals and I'm working on my right side. This tells me eventually where I had started from. I'm not going to keep repeating that down because it does hold the same. Now I'm going to go look at b. Okay, and our b is going to be the trickier of the two, which is going to be f minus g of x. Now, this is where a lot of you tend to ignore that subtraction sign, and that will get you into a lot of trouble every time. First, I'm going to take my f, and I'm going to write 4x plus 7. Subtract 12 plus x. Now, here's what's important. This is what I should be doing. I should be writing it just like this. Okay? This function is going in here. That function, is here. This function is here. But look at my subtraction sign. Do you recognize that he should be traveling through this whole thing, just like we learned way back in elementary or junior high? So let's rewrite it so we see that better. 4x plus 7 plus the multiplication and negative 1 times this. That minus is really this. Now, am I going to do this every time? No. But I want you to understand that what I should be doing with that negative is running him through every single piece. So 4x plus 7 minus 12 minus x. Again, combine like terms. 3x minus 5 is my final answer. If I'm giving a test, I am picking things with subtraction signs to put on there, because I know this is where you're going to mess up in distributing that negative. Okay, so be careful. Okay, do not let that get you. All right, let's look over at example 2. Okay, so example 2 is going to have two functions. F of x equals x squared minus 9, and g of x is equals x plus 3. So this is a nice little review for us. So on A, we're going to be doing f times g of x. And I'm going to do just what it says. F of x is x squared minus 9, and I'm going to multiply him to x plus 3. Okay, remember our first outside, inside, last now. I'll use a different color so we can see a little bit better. First, and for some reason I've been liking to do 2 times 1 and not changing it. Remember, that is a cubed. Outside, inside, last. I double check, make sure I don't need to combine anything. And what I do notice right here, I'm just going to clean this up a little bit. So I have x cubed plus 3x squared minus 9x minus 27. Let me make sure. I think I got that right. This is a third degree function, meaning it is a cubic. All right, so don't forget those like little things that we learned back in Algebra 1. And then B, we are going to be doing f of g of x, or f divided by g of x. So this is going to look this way. F of x, x squared minus 9, divided by x plus 3. Now, here's the struggle. This is an Algebra 1 concept. We learned how to factor this way back in Algebra 1. Some of us may have forgotten. This is a difference of 2 squares. X squared is a square, 9 is the square of 3. So it's the difference of 2 squares. So I square root, and then I have to flip the sign. X times x is x squared. Negative 3 times 3 is negative 9. Notice the middle portion. 3x and a negative 3x cancels out to a 0x. That's why there's only 2 terms. And I'm going to divide through by x plus 3. These go away, and this is going to be now x minus 3 is my answer. But, and this is a big but, if I look up here, if this had been a negative 3, if I gave you x is 6 and told you to solve, you'd solve it. But if I told you x was negative 3, this would become a 0, which makes this undefined. So I'm going to write x is not allowed to equal negative 3. And that would be my final answer. On these problems, it is imperative that you are taking your time and writing them out line for line, not skipping any steps, so that you don't make any careless mistakes and get yourselves caught up. All right? Best of luck in this section. Again, use clean paper, line by line. Good luck.